All right, guys. So today we are going to be talking a little bit more about the electromagnetic spectrum. So we had an intro to that with our Bill Nye on Friday, and we're going to be going a little bit more in depth today. So our electromagnetic waves can travel without a medium. So what that means is that they can travel through space. They don't need to travel through something. What a medium is just a material that energy travels through. So electromagnetic waves don't need to travel through something. They can travel through empty space, or they can travel through different types of materials. So that's something that's special about electromagnetic waves. Electromagnetic waves are also very, 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 very fast. They all travel at the same speed, which is the speed of light. So at that speed, they could go around the entire Earth 8 times every second. So they are very, very fast. So our electromagnetic spectrum, that is the name of all of our waves put in order of wavelength and frequency. So if you see on one side of the spectrum, on our radio wave side, you see our wavelengths are longer, the waves are further apart, and then they get closer together as we go to the other side of the spectrum. So that's the difference between the different types of electromagnetic waves. They all have different wavelengths and different frequencies. Same thing with light. That visible light spectrum is split up. Those colors, the reason we see different colors is because they have different wavelengths and different frequencies. All right, so now we're going to go a little bit more in depth into each type of our waves. So first off, radio waves. Those are our longest waves. So they have the longest wavelength, the biggest wavelength, and they have the lowest frequency. Remember, in our Bill Nye, we looked at the relationship between wavelength and frequency, and they're opposite. As wavelength goes up or gets longer, frequency goes down. So our long waves have the lowest frequency, and that's our radio waves. So radio waves, GPS use radio waves. That's one example of how they're used every day. Obviously, radios use radio waves. What it does is your antenna picks up that electromagnetic wave traveling through the air and converts that into a sound wave, which is a little bit different. And we'll learn more about that later on. And MRIs also use radio waves. Next up, we have microwaves. So microwaves have a little bit shorter wavelengths and a little bit higher frequency. So microwaves are going to be used in microwave ovens. Those waves are what transfers energy into your food, which makes it heat up, because heat is also a type of energy. It's also used in radar, so looking at how fast something's going. What it does is a radar, it sends out a radio wave, measures how long it takes to go there and bounce back, and uses that to determine the speed that something's going. And next up, we have our infrared waves. So we're getting a little bit shorter, and our frequency is getting higher. So infrared wave, we feel that is heat. So when you feel heat coming off of something, you're feeling infrared waves. So things that are warmer are going to give off more infrared waves than things that are cooler. And that's actually how heat cameras work, or thermal imaging works, is they sense those infrared waves. As you can see here, the red spots have a lot of infrared radiation, and the darker spots have less. Next up is visible light, which is one you guys are all familiar with. So again, wavelengths are getting shorter, wavelengths are going down, frequencies going up. And these are the only electromagnetic waves that we can see. All the rest are there, but they're invisible. Visible light, we can see. Everything that we see is visible light. So the difference between colors in the visible light spectrum is the wavelength. So our red's going to have the longest wavelength. And purple, on the other way at the other end of the spectrum, that's going to have our shortest wavelength of light. Oop. So the reason why we see rainbows, so when we have white light, when we have light from the sun or light from a light bulb, it is actually made up of all the different colors of the rainbow, all those different wavelengths of light. What happens to light is when it enters into something new, like into a prism, which I'm sure you guys have seen, or into things like raindrops, it causes that light to bend because of something called refraction, which we'll learn about later. And what that does is because these waves are different wavelengths, they bend at different angles. So it splits that white light up into all of the different colors that make it up. So that's why when you put light through a prism or through raindrops or anything like that, you're going to see a rainbow. All right, next up we have ultraviolet rays. So again, we're getting even shorter and our frequency is getting even higher. So ultraviolet waves have a lot of energy. So energy is going to be tied to frequency. If something has a low frequency, it has low energy. If something has a high frequency, it has high energy. So we're getting to the point where we have a lot of energy, where these waves could do some damage to you. So ultraviolet waves are actually used to kill some types of bacteria. So it can be used in sanitizing things. So with COVID, all these sanitizing contraptions have gotten really popular, and most of them use UV light, like the ones that you can put your phone into that uses UV light. The sanitizing boxes we have for our safety glasses that we wear at school, those also use UV light to kill bacteria and sanitize things. UV, ultraviolet waves, are also what causes sunburn. That's what damages your skin coming from the sun, and too much of it can cause skin cancer. Ultraviolet waves are also good for us. It creates a chemical reaction in our skin. It helps our skin to produce vitamin D, which we need for healthy teeth and healthy bones, which are important. So moving on up to X-rays. So those are even shorter and higher frequency. They have a huge amount of energy and can go through almost everything because their wavelengths are so small. So X-rays are obviously used for X-rays. So how X-rays work is our bones and our teeth actually absorb X-rays. So that's why when we see an X-ray image, our bones and teeth appear white and the other areas appear black because they're absorbing that X-ray. And too much can cause cancer because, again, we're up in that area where we have so much energy that if we're not careful, they can do some damage. It's used by engineers to check for cracks in structures, which is really cool. They can actually X-ray like buildings or bridges or images to see if there's any kind of internal damage in them, which is really important, especially after things like hurricanes. All right, and our last one, we are now at the other end of the spectrum. These have gamma waves, has the shortest wavelengths, the highest frequency, and the most amount of energy. So these are going to be what's used in radiation treatment to kill cancer cells, but it can kill any cells. So if it's not used correctly, it can be dangerous because it can kill other cells as well. The Incredible Hulk, I don't know if you guys have seen the Hulk, but how he got his powers was through gamma radiation. And exploding nuclear weapons also emit gamma rays. That's why nuclear weapons do so much damage, because those gamma rays carry so much energy. Oop. So just a summary of all of that. Our electromagnetic waves, they all travel at the exact same speed. That's one thing they all have in common. What's different about them is that they have different wavelengths and frequencies. And because they're all traveling at the same speed, these wavelengths and frequencies are going to be related. When we have long wavelengths, it's going to take longer for those waves to pass by a point, resulting in a lower frequency wave. If we have really itty bitty tiny little short wavelengths, those waves are going to pass by a point pretty quickly. So we're going to have a lot higher frequency. And then frequency and energy, those are tied to each other. The higher the frequency, the higher the energy. So if you remember, frequency and wavelength, those are opposites. When one goes up, the other goes down. Frequency and energy, they're the same. So if one goes up, the other one goes up. And this is just a picture of our electromagnetic spectrum. So you can see it laid out. Down here, it gives you our frequency, which you can see increases as we go up to that gamma rays. And if we had the wave illustration on here, it has the numbers, but it doesn't have the illustration. You can see our waves are a lot longer down here by the radio waves, and then get shorter and shorter and shorter as we go up to the gamma rays. So you can see wavelength and frequency, they're opposite. This one goes up as we go toward gamma. And this one goes down as we go toward gamma. So that's all we have for our little electromagnetic spectrum intro. What you guys are going to be doing next is you're going to be working on a little web quest, looking more into the electromagnetic spectrum, and that's going to be under your classwork tab. So you guys are going to go ahead, open up your classwork tab, open up the electromagnetic spectrum web quest, and that is what you are going to be working on for the rest of today. And we will probably be working on that tomorrow as well. As always, if you have any questions, email me. This is a lot of information. I know we're going to be spending quite a bit of time on electromagnetic spectrum, so don't worry. I don't expect you to remember everything all of this first time hearing it. We're going to be going over it quite a few times. But let me know if you guys have any questions about the assignments. Email's the best way, just like always. I'll see you guys later.